Okay, today we're going to work on lesson 5-6, multiplication of fractions and whole numbers. So we want, by the end, we want to be able to discuss and apply strategies for multiplying fractions by whole numbers, apply and extend previous understanding of multiplication, division, to multiply and divide fractions. So those are all the things that we will be working on today. So to start with, to get warmed up here, we want to round the following decimals to the place value identified. So if you look here, it says round 87 3/10 to the nearest whole number. So a lot of people seem to struggle with this. Remember, the whole number would be the first one here that we're really focused on. So then we go to the right of the place value we're rounding, and 3 tells me to round down. So instead of 87 3/10, it's just 87. Okay, let's look at the next one here. Round 99 12/100 to the nearest tenth. So I know I'm working with the tens place here, or I should underline it. So I'm working with the tens place. I look at the hundredths, it's a 2. So then I can also look at this and say is it's between 99 and 100. And in this case, it's 99 and 1/10 because the 2 tells me to round down, so the 2 becomes a 0 or just drops off. And the last one here, round to the nearest tenth. So I look here in the tenths place. The 8 tells the 1 to go up because it's 5 or above. So I get 3 2/10. So the key thing with these, remember, just pay attention to which place value are you rounding to. Here's a few more that you can go through and work out on your own. So this one here, you can see round to the nearest tenth. This one says to the nearest hundredth, and again, pay attention to that TH at the end, and round to the nearest hundredth. Now, the next thing we want to do is go ahead and complete problems 1 and 2 in your math journal. So that's page 169 in Math Journal 2. So go ahead and pause the video and then come back and we'll go over that. All right, so you should have worked out these problems already, so let's just go through and look at them. It says use the rule, multiply by 1/5. And then over here it says divide by 5. Okay, so if we multiply by 1/5, we do the n. And I just multiply by 1/5. Now, I always like to put my whole number over 1 when I'm multiplying fractions. So I get 15 multiplied by 1, and I get 15, and then 1 multiplied by 5. And now, I don't want to leave it as an improper fraction, so I say 15 divided by 5 is 3. So I do the same strategy for each of these, and I get 4, 7, and then 2. Okay, so again, you just write your whole number, the n, over 1. And then you multiply it by 1/5. You multiply straight across. Remember, multiplying fractions is different. You do not have to have a common denominator to do that like you would with addition and subtraction. So that's a key thing to remember. Now, if we look over here, if I just do 15 divided by 5, I get 3. If I do 20 divided by 5, I get 4. Okay, do you notice a pattern here? Multiplying by 1/5 and dividing by 5 is the exact same thing because 1/5 is a unit fraction and then 5 is what you end up dividing by. So dividing by 1/5 is the same thing as multiplying a whole number by 1/5. So imagine if I give you another n number. Would the out number be the same for both tables? So think about what we just talked about there, that multiplying by 1/5 and dividing by 1/5 is the same thing. So fractions can be interpreted as division. For example, 1/5 equals 1 divided by 5. So remember, we've talked about that previously, that fractions can be written as a division problem. Therefore, think of the rule 1/5 as 1 divided by 5. Because multiplying by 1 has no effect on the number, the rule multiply 1 divided by 5 produces the same result as dividing by 5. What is a division rule that would produce the same number as 1/3, and why? So let's think about that for a minute. If we said that 1/5 is the same thing as dividing by 5, I think about this and I say, okay, well, I see there's a 1 up here, and that's the same as the 1/5, and there's a 3. So I know if I could divide by 5 is the same thing as multiply by 1/5, I could conclude that I could divide by 3 to represent multiplying by 1/3. Because they're unit fractions, the top number, the numerator, is a 1, so we can do that. So the previous lessons, you used your understanding of fraction of problems to multiply fractions by whole numbers. So today you will think about fractions as division to help you multiply fractions by whole numbers. It does seem kind of funny that we would do it that way, but it does work. So examine the rules for problem 3 and 4. The n numbers are the same for both problems. Do you think these rules will produce the same out numbers? Why or why not? So they use the same n number, so I want you to think about that. If it's dividing by a unit fraction, will it be the same? Okay, now I want you to pause the video and complete problems 3 and 4. Interpret problem 3 as a series of fractional problems and to complete problem 4 by multiplying and dividing. So pause the video now and complete those and then come back. Okay, so after working these out, it's a little bit different, isn't it? So now we're multiplying by 3/5. So I could have done 15 over 1 multiplied by 3/5. And again, it's still the same rule. I'm going to multiply across, and I know 15 times 3 is 45. And I know 5 times 1 is 5. And I know 9 times 5 gives me 45, just like the out. Okay? So let's see if we get the same result over here. Now it's telling us to multiply by 3, divide by 5. So let's take the n, multiply by 3, and divide by 5. In order of operations, if you remember, multiplication, division, whichever comes first, going left to right. So 45 divided by 5 equals 9. So you get the same result. So we could read this problem as multiply 3 divided by 5. And over here, it's just written out that way. Multiply 3 divided by 5. So you could even skip putting the 1 and just multiply times 3 and then divide it by 5. And you can see both in and out tables are exactly the same. So you're going to go through in your own words, describe 2 strategies you know for multiplying fractions by whole numbers. So think about the strategies you know, so you can use numbers and words, combine those 2. Give an example of how you would use that strategy. So take a moment, pause the video. Okay, so let's look at what they suggest here. First, you can make a unit fraction using the denominator of a fraction and find the fraction of a whole number. Then multiply your answer by the numerator of the fraction. Another example, you could interpret the fraction as division, like we talked about. So you can multiply the whole number by the numerator of the fraction, then divide your answer by the denominator of the fraction. So we looked at both of those strategies on the previous problems with the in and out tables. All right, so go ahead and pause the video, and you're going to go ahead and complete problem 1 on page 270. All right, so let's go ahead and look at problem 1 together. And so problem 1 is 13 multiplied by 2/3. Solve the problem by thinking about 2/3 of 13. So I could use 2 different strategies here. I could write it out as 13 multiplied by the numerator 2 divided by 3. So if I do that, I get 26 divided by 3. And I got to do some division over here and then write my remainder as a fraction if I have one. And let's see, I know 3 times 8 is 24. So I subtract and I get 2 left over. Now I can't do anything else, so I get 8 and 2/3. So I know that 2/3 of 13 would be 8 and 2/3. And that makes sense to me. That seems reasonable because it's not more than 13, right? If you got an answer more than 13, then you would know your answer was not reasonable because we're only finding 2/3, part of the 13. Okay, so I'll erase this here so you can see this explanation they gave. Okay, so you can see here what they did. First they found 1/3 of 13, and then they were able to add the 2 together. Or you could just multiply 4. So they did 4 1/3 by 2, or doubled it. Okay. Personally, I like the strategy that we did better, but you can do either one. Okay, so B, solve the problem by thinking about 2/3 as 2 divided by 3. Okay, and that's actually kind of what I did over here on this section. So take a minute, go ahead, pause the video, see if you can solve it. We already know the answer is 8 and 2/3, but we want to see you use a different strategy. All right, so you can see this is more the example that I gave on this side, and you still get 8 2/3. So either way works. So over here, they decided to find out what 1/3 of 13 was, and then multiply that or double it. Now you're going to go ahead and pause the video, and you're going to complete problems 2 through 5 at Math Journal 2, page 170. So pause that, come back when you are done. Okay, so you can see 2, 3, 4, and 5. Use any strategy that you would like there. So I'm going to do number 3 here. So let's look at this one together. So you could do 20 over 1 multiplied by 5/8. This is the way I like to do it because it's what I'm used to. So I get 100 over 8. Now I read that as a division problem. That's 100 divided by 8. Let's see, I could do 10, right? Because I know 10 times 8 is 80, and I get 20 left over. And I know 8 times 3 is 24, so that won't work. So I could do 2, I get 16, remainder 4. So I get 12 and 4/8, or 12 and a half. So take a minute, study that, and then we'll reveal the answer so you can check your work on that one. So after you do it, again, you should get 12 and 4/8. Okay, you should have already done number 2, sorry. So you should get a whole number of 12. Remember, if you get an improper fraction, you need to divide it out and write your remainder as a fraction. So let's look at these story problems here and use cubes. So number 4 says Lydia had 10 feet of ribbon. She used 4/5 of it to tie a bow on a large gift box. How much ribbon did she use? Well, first we need to do a number model, so I need to know my numbers. So she had 10 feet of ribbon. She used 4/5 of it. How much ribbon did she use? So of tells me I know I'm going to multiply, right? So I'm going to take 4/5 of 10. So I'm going to say 4/5 multiplied by 10. Okay, and I'm going to put that over 1, and I get 40 over 5, which you can go through and do the rest of that there. So you would read that as 40 divided by 5, which will give you 8 feet. Okay, so after you figure that out, you figure she used 8 feet. So let's look at the next one here. In a classroom, there are 14 cubbies along the wall. Each cubby is 5, 6 foot wide. How long is the line of cubbies? Okay, so we know there are 14 of them, and we want to multiply that by 5, 6, because each one is worth 5, 6. So 5, 6 multiplied by 14. And I know, let's see, 50 should be 76. And I can see I got an improper fraction, so I'm going to go back up here so I have a little more room, and I'm going to divide this out. I know 6 times 10 is 60. And I know 6 can go into 10 one time. I get 4 left over. So I get 11 and 4/6. So how long will the line of cubbies be? 11 and 4/6 feet. Okay. Let's check our answer there. 11. And they said 2/3, which is just simplified. And also one other thing, point out that I did put on the number model, make sure you put a letter for the answer because we don't know it yet. So R for ribbon and C for cubby. So make sure you did that as well if you didn't already. Okay, then you just have a home links 5, 6 that you can look at for extra practice. All right.